All right, so for those of you that are not here today, the first thing that we did in class, which I forgot to video, was we went over this worksheet. So you can just kind of look here is all the work on the worksheet. And you can just kind of pause the video right now and see all that work. And then only thing I want to kind of point out is on number 8. This is a limiting reactant problem. So to review limiting reactant, you don't just guess which one to use. Convert each to moles using the molar mass, and then divide by the coefficient. Whichever number is smallest is the limiting reactant. That's the one you use then to determine the moles of ammonia, then put it into the ideal gas law. Okay? So everything else is pretty straightforward. And then we do have a test on Monday over all of this, and I'll post the study guide that we're going to work on in class as well. All right, so let's talk about our lab. Okay? Let's talk about the lab. What you are going to do is calculate, the purpose of this is to compare the volume of hydrogen collected versus the volume predicted using the ideal gas law and stoichiometry. Okay? That's the ultimate goal of what we were doing. Now remember, for those of you that weren't here, we had a big 2-liter beaker, half full of water or so. Then we put that tall gas collecting tube full of water into this, so it's full of water. Okay? But at the well, it's not really completely just water, right? What do we have it, what do we pour in there initially? Up in here, we had some concentrated HCl. Hydrochloric acid. And then we had a piece of magnesium on a string here. Okay, so we had a chunk of magnesium down here. So in the magnesium combined with the HCl, what did it make? Well, what's the formula? Magnesium chloride, but when we write the formula, what do we always balance? Charges, so it's magnesium chloride, but what's the charge on magnesium? What's the charge on chloride? So the formula is? And what happened, what did we observe with the magnesium? It disappeared. But did it really disappear? It dissolved as magnesium chloride is soluble in the water. So what state do I put here? Aqueous. So it was still in our water. And then what was the bubbles? Hydrogen gas. Okay, and then we balanced that with the 2. So that's my reaction. So when the acid came down and hit this, it began to bubble. And then what happened to the water that was in the gas collecting tube? It pushed out and came out, okay, and was displaced. So we collected the gas by water displacement, okay? And then we made the levels equal. Once we pushed out, we used just the right amount of magnesium, theoretically, hopefully, to where then we could make the water levels equal. Because then what was true?
The pressure.
What pressures? Was equal to, not the vapor pressure. What other pressure? What was it equal to?
Oh, the pressure of the gas.
The pressure of the gas on the inside pushing down. So the pressure of the gas on the inside. Now, was the only gas hydrogen?
No.
No. Water. So the pressure was equal to the pressure of the atmosphere, which we determined was pretty much right at 1 atmosphere, wasn't it?
It's 30.01.
30.01, which I think came out to 1.02 atmospheres.
Do we do this to calculate the pressure of dry H2 gas?
Yeah, that's gonna be this. Is gonna equal the pressure of the hydrogen plus the pressure of the water. Right? So what temperature did you measure the water? The water is 17?
We had 19.5.
I had 22.
22 is a little bit more realistic, but those thermometers were pretty sorry if you got 17.
We had a sorry thermometer.
Okay? So you have your temperature. So how do you get the pressure of the dry gas?
Oh, you go to.
And by the way, for this book over here, I found the missing page. I don't know if you noticed, that might have been the other class that
You
noticed that.
subtract the pressure of H2.
Okay,
from
so-
regular pressure.
So once you have all of this, the goal is to get the volume. So volume is equal to the moles of hydrogen times R times the temperature of the hydrogen divided by the pressure of just the hydrogen.
If ours is like directly like 19.5.
You just gotta guesstimate, and most go up, because you're probably was closer to 20 than it was 19.5. Now, hey, listen, last thing I'm gonna tell you, how do you get moles of hydrogen? What did we start with? What did you measure? Grams of magnesium, right? And it was about 0.04 something grams of magnesium. So how do I get moles of hydrogen?
You have to do the mole mass.
Okay, so that's what your problem is now, so I'm not gonna go any farther than that. So you know you have grams of this, so this is just like the sheet problems we just did. You're given grams of this, we wanna know how many liters of this, or milliliters of this, were formed at these conditions that you measured, the temperature and the pressure. And then, that's the amount predicted by the ideal gas law and stoichiometry. You actually measured the volume on the gas collecting tube. So then we want to calculate our percent error. Does anybody remember percent error?
It's a little over. No, that's.
It's your experimental value
Minus zero.
minus the theoretical divided by your theoretical value.
You're off this though.
Stoichiometry gives you your theoretical value. Your experimental value is what you actually read off the burette. Okay? Everybody following me on that?
A little bit.
So we're comparing what did we measure, what did we actually collect, compared to what does the ideal gas law and stoichiometry predict we should have collected. And unfortunately, they're not the same.
How you could, what's the, like, the pressure of the atmosphere?
Wait.
It's 25.4 millimeters is an inch.
Wait, for number 2, for calculating the moles of hydrogen gas, I got a very tiny number.
Well, you had a very tiny
Okay.
25, and remember, you're calculating it in liters. Or moles, well, you're doing moles, but.
You do moles and then liters.
That's your conversion factor right there. That gets you millimeters of mercury. Now, how many millimeters of mercury are there in an atmosphere? 760. What does that come out to? 762?
0.25.
Yeah, so divide by 760 and you get atmospheres. Or you can use millimeters here and just use the 62.36. You probably want millimeters because the water vapor pressure is in millimeters. Okay? 5 minutes. 5 minutes to kind of get started on that and ask me any questions, and then we're going to move on. And I'm gonna go, during that 5 minutes, I'm gonna print off your copy.
What's the,
I promise.
Of the lab?
Huh?
Lab? I don't have any.
Yeah,
Do you have anyone?
yeah, I don't know what, I've lost 2 folders. Getting old sucks.
Do I need to
No, that's on camera. That's okay. I can be quoted on that. Go back and rewatch all the titles.
I saw I shot one in here, so I didn't go back.
Wait, the guy that's saying he's like 500, right?
Yeah.
Yeah, but that's not that far off.
Yeah, more shots.
I mean, everybody has one good day, and they have 4 good days.
Yeah. I don't know. But the dude who's in first is like, he's not like top 30 in the world, so.
Yeah, they'll probably show.
He'll probably choke it, yeah.
There's one dude who was a couple of years ago, I remember he was up by like 4 or 5 strips on 31.
And then he choked.
And he choked.
Oh, wasn't that the guy that came back in?
Oh.
Oh, yeah, he's like, all he had to do was sing.
Hey, let's work on the lab. Luke, work on the lab.
I was just writing down.
What do you think he's trying to
Oh, we're doing mold, yeah.
Yes, ma'am. Okay, you can find that in the textbook. Go to page 1099, and then use whatever temperature, 22, and find it, what it is. 1099.
We did one while everyone
break the match with?
It's just zero. Did I have questions?
Wait, does Sam have a math quiz as well today?
No.
Yeah, you should.
Oh my.
Like we do.
It was Monday.
Yeah, it's on cosine secant.
I swear it was
No,
Monday.
we have.
It was Monday, and then you're playing with me.
I know.
I swear he said that.
On the calendar, it is on Monday.
Let's go, stay focused. We don't have much
We
time.
can allow the calendar. Come on, man.
You like the calendar of the day that says
I
it.
think we do have a quiz. Yeah. He gives you 10 minutes.
Oh, right.
Searching the circle is finding a cosine of 420 times the tangent of 80 or whatever.
Wait, follow me.
You get the
Yeah.
Unit circle, right?
Yeah.
We're gonna review Tuesday, and then first priority is on Wednesday. And then
First
we're gonna
priority.
graduate.
Is it first priority to you?
0.04.
What'd you say?
Bro, we literally said quiz Monday.
Was it off the unit circle or was it just like?
Okay, for those of you that aren't here, I need you just to copy the other person's data and then do all the work. Copy somebody's next to your data.
Is it 62.36? 62.36.
62.36.
I didn't know what it was.
Okay, and then on your study guide, the last part got cut off at the very bottom. This is what it says right here, so you need to just write that in. On the study guide I just gave to you. This is on the very bottom of the front page, the very last question should be this one.
Do you have to turn the study guide?
No. Okay, that's what it says. You can kinda see the top part of it, you can't see the bottom part of it.
Yeah.
You had a very high percentage.
Oh.
43.5.
Why did I?
How many milliliters did you predict to get, how many did you get?
That's a lot. How did we get to?
Whoa.
Oh, I did.
Since you got 30.
Can't see that.
Eight.
Wait, is
Can you
it,
see
no,
the
we
middle?
put, yeah.
7.4.
You only got 30.4?
Wait,
No, that's the
There's no way that.
what's
I think
percent?
that's pressure.
You know, wait, can you zoom in on this? Cause like we can't see what the CH and all the
Yeah.
numbers are.
How can you not see that? You guys, I can read it
I
from
can't
the.
Because
even
we're
see
like
it.
a
I
mile
can't
away.
see it.
Yeah, we're like-
See about it?
There we are.
There you go.
Wait.
Remember, we're the new generation. We were born blind.
Shit. It's cause you stare at your
Exactly.
Xbox too long.
It's actually supposed to be.
Yeah, this
It'd be what you got minus what it should be.
So,
Hey, I was too busy watching the Braves get clapped.
Dude,
Oh
shut
my
up.
God.
That's so bad.
We're all
Dude,
done.
they literally hit the ball like 50 miles an hour and we're getting base hits. That is the dumbest thing ever.
Well, you're not counting the
Okay, dude,
pressure,
that-
you're counting the you know the pressure.
He thought he was gonna turn around and, you know. How many
Now we
points
draw
track
H2, all you have to do is subtract,
like 7.
once you have 30.01 inches.
I was gonna post something on my story, but I know the Blue Jays are gonna lose to the Blue
Subtract
Jays.
Yeah,
value
no,
of
the Rangers are
water
gonna score like
pressure
1 run
back
every
to
game,
up.
so it'll be fine. What's the, so wait,
Left
since
hand
there's
side
like
water
minus
displacement, the pressure is behind there. Total pressure, the pressure of the hydrogen plus the pressure of the water. The total pressure is just the pressure. All this is
Why are you so slow?
Wait.
You can't read
Yeah.
Wait, what
Okay,
is
so
it?
That's the thing.
we measured the pressure to be 30.01 inches.
Oh, yeah.
30, is that right, Leo? 30.01?
Yeah,
And you multiply that by 25.40.
actual is what you thought, right? Theoretical is the field.
Theoretical is the stoichiometry, all the math.
Okay.
And the actual is what you measured off the, in the experiment.
Wait, so percent error, that's what we got, nice and track. So that, I need to split this.
This is what, no, this is what you got, minus, you're a little bit over, okay? And now, you don't have 90.3. You got, you subtract those, you got like 0.12 divided by 46.
Zeros.
I don't know.
Oh, wait,
Dude, let's see, I think our percent error is kind of pretty good.
We're supposed to use, the gas lamp.
Yeah, so the stoichiometry.
Dude, we did 16% error, that's pretty good.
Do we not need to change that?
Wait.
So why did you go to 0.00125? That's the problem.
You're agreeing.
Okay, hold on, wait,
Actually, guys, we get to time this
Not
out.
Well, yeah, I want these. Oh, wait, you
I hear what he's saying.
No, it should
But I
have
don't- I
been
still
0.04 something, it's 0.04. All of
That
it.
mean again?
All I can all this stuff.
Minus 1.18, all over. That's, I think we got 35.
This is,
That's your, that should be, you guys put it.
that's.
Oh, around.
Yeah, so just do 44.
Cause they're all need to be, they're between 0.040 and 0.05.
I would do one more digit. So I did that.
Yeah, 0.25. You have very, very low percent error
then
because
times that by
you just
Dude,
barely off.
Wait, what about a
No,
point
it's
six?
just, yeah.
Wait, is that a point 16 a good, like, we got point 1.5.
Percent?
We got under 1%.
That's great.
Wait, so like that's our percent, we don't times by 100 again and get like.
No, we got 0.158. That's less than 1%.
Yeah. Now, blind squirrel finds a nut every once in a while.
No, it was more like it was more like me going to the major leagues like can't go out there, like, it's like a blind squirrel with no
Okay,
eyes.
atmospheric pressure right here.
With no
Multiply that by
Acorn
0.24, and that gets you the
Yeah,
total
yeah,
pressure.
acorn is so big.
Okay, that's that
Acorn were like,
value.
here, I got you in a second.
That is a barometric pressure.
I know,
Total pressure is the atmospheric pressure, the barometer.
0.1.
That's gonna equal the pressure of the hydrogen plus the pressure of the water. So to get the pressure of the hydrogen, you have to subtract barometric pressure minus that 19, the vapor pressure, that gives you the pressure of the hydrogen.
Oh my god, that's an A.
All right, now, once you finish this, let's start working on the study guide. The study guide.
Oh my god.
You just ripped his
You know what, I think it's workable. Yeah, it's workable. I need to copy this back down.
You said what?
Oh god.
Yeah, but we're gonna have to turn it in on Monday. Or, I gotta make the thing to turn it in.
Oh, so we are, this study guide is due.
The study guide is not gonna be due, it's gonna be a study guide. Okay? Now, I strongly recommend that you do it. Now, I'm debating whether I'm gonna post answers or not.
Please
Oh,
do, I
please.
can't.
I would say do, I really do.
Okay, but all the answers, but I want you to go through, all the answers are in your notes.
Yeah, but it makes it easier if they're all like.
Yeah, it does.
I just need
Well,
to-
that's why you go through and you figure them out and you put them in one place. You want me to do the work, but if you do the work, you're gonna learn it better.
Oh, I swear I'll do the one. I swear, I swear.
Yeah.
I will swear.
I promise you, I'll click on the answer sheet and look at it. That's your
No, I
work.
promise I will have it
Make
done.
their best on it.
Okay. You got 15 minutes.
Boom, that's
So
it.
you're not making study guide bonus?
I am not. However, I am gonna make number 18 on the study guide bonus.
Why?
No, I'm gonna make a problem like number 18 bonus on the test.
Oh.
Wait, what's the bottom of the map too?
Is that the cube?
The
Okay.
back on the.
All it says is like done in class.
Okay.
Okay, and that was done in class the first 9 weeks.
Okay.
That's the Q total is equal to the Q ice, Q melt, Q water, Q boil, Q steam.
Okay.
That's why I'm making it bonus.
Okay, I'm gonna do that.
It's just, you just come back.
And you subtract that, then what goes
Or, no, I think it's 760.
That's all you do for the pressure of the gas.
That was the times.
Whenever you're collecting the gas by water displacement, the pressure of the dry gas is the pressure of the barometric pressure, the atmospheric pressure, minus the water vapor pressure.
I do,
So that's a simple calculation.
Hey James, we have read this English already. Okay.
Okay, now I got 0.04.
Who in here is actually a little
No,
we're
we're
good.
same dudes, we're just not hard.
Yeah,
We're like,
we have, okay,
for the, I like it, I'm not doing.
Yeah.
Which one goes first?
But like, when it tells me, it tells me like,
Which one goes first when you have percent error? Would it be
What'd you get?
this? The one you got is the one, is the X.
No matter what it is, it's what's the.
What it should be.
What's your percent?
This is lead, this is
The exponential value. Yeah.
Oh, wait, I got
I got number one right.
Alright, hey, let's go, use your time wisely now, come on. There's way too low ratios.
That's what it is.
What?
So if you change this to no, you just move this over. No.
Bigger. That.
High pressure.
There you go, and then that's what you want to put.
That's when they become very unfortunately. High pressure, pushing together, no rolling is gonna get away from that. And low temperature, and then attractive forces.
No, hold on.
No.
I got 0.4.
Okay.
Do you test for number? So when you say deviate from,
They deviate.
First off, there's, all of this.
Yeah, it's right here.
Okay.
yeah, I had it down.
So we're only off like 2 milliliters.
Just the
If you
total
change
pressure.
liters to milliliters,
No, I actually did get.
you get the same
I
answer.
got 0.117.
I think.
Pressure.
Would it be?
And then,
That's a milliliter.
That's a milliliter.
multiply by 16.
It's not 417 milliliters.
It would be.
40,
No, you times it by.
41.7.
No, milliliters.
What's this pressure? Where is that?
Yes, you should have had an extra
I
zero.
mean, no.
Closer to a gas. Closer to a gas.
Is it only 4.1?
Why would an ideal gas deviate?
So what the fuck is the
That's what it
Because
is.
the closer a gas is to be.
Mr. Ha.
The closer to it.
Unless I had it.
Closer to school.
Yeah, no, wait. Let me finish. I said the closer a gas is to a liquid. You know what I'm hearing? All I'm hearing is food isn't going away. Okay, no, but I'm just saying that. Okay, they're really good. Madison overrated.
Mr. Hobbs, I think we need some help.
Marcelo Zuna beat his wife up. They hang their baseball. Okay?
No, it just means he's good at hitting.
It's just gonna be whatever you get.
He should be
Hey, guys, I'm getting tired of over and over and over, so the same thing. Okay, and by the way, stop the video.
Oh, all of us just screaming at each other.
Screaming on the video.